Hello guys, welcome you all for this end-to-end session on AIML, where you guys gonna learn everything that you guys need in order to become a successful data scientist. So the theory, the black box behind each and every algorithm, the coding part, everything that you guys gonna learn. So hope you guys are enjoying. We are enjoying and we are learning a lot. Every day we are just learning a lot for due to you guys. So thank you for that. I hope the same thing for you guys. So yeah, welcome you all again. So today is a coding session for K-means. So for the past two sessions, we have introduced you what is the black box behind it, what are the theory concept that behind it, the K-means that we have discussed. Okay, today is completely a coding part, guys. If you doesn't watch previous two sessions, then you guys doesn't understand the black box behind it. That's the only thing that I can do. So only thing, make sure that you guys watch all the previous session videos so that you can have a better understanding of what we are saying. Okay. So yeah, without wasting any time, let us jump into today's session. Today's session is purely coding session, guys. Okay. Okay. I hope if you guys watched nearly like 10 to 12 sessions of coding, now you guys have an idea how the flow will be, right? First, you need to import the necessary libraries, load the dataset, pre-process the dataset, go for splitting the dataset to input and output. Then we need to go for something like feature scaling, train and test it. You need to load the model, train the model, fit it. That is, you need to train. So training is called as fitting. Then you need to predict. Finally, you need to go for accuracy score. Then you need to predict for a single data point. This is a flow. Any algorithm in the machine learning, deep learning, artificial, anything, this is what the flow. Okay. Hope you guys have noted down. Okay. If I'm very fast, make sure that you guys slow the speed of the video and then go for it and then write it down. Okay. These are the flow that we're gonna have. Okay. Yeah. So without wasting any time, let us jump into today's session. Today's session is a coding part of K-means clustering. It will be simple. Okay. I promise it will be simple. Okay. Let's move on. First step, we're going to import the necessary libraries. NumPy, it's used to perform a mathematical operation. Pandas is used to perform, it is used to treat the data in a form of a data frame. Matplotlib, the pyplot, PLT, you know, right? If we are going to use this for data visualization. Whereas from dataset, I'm just loading the inbuilt dataset, that is Iris dataset, where we're going to have a flaws features. You guys, if you guys are watching our videos, you guys already know how this dataset looks. We will be having three different features of flaws: Setosa, Virginica, and vesicolor. Based on the sepal and sepal width, petal and petal width features, we will classify which kind of class it is. Then we are having standard scalar. So in order to standardize the input, then we are just importing from sklearn.k-means. Sorry, sklearn.cluster. We are just importing the k-means. That's it, guys. Actually, we have learned nearly like 45 minutes, 45 minutes, 1 hour class. It's just one line. Okay, now you guys can able to understand, because like as we are mentioning, right, only two lines of code we need in order to load the model, fit the model. That's it. Okay, then we are having silhouette score. So in order to calculate the accuracy of this clustering algorithm, we are using silhouette score from matrix. Now let's move on and load the dataset. Iris equal to load iris, so it's an inbuilt dataset, and our x, that is our input, that is iris of data. Our output is iris of column. So iris of data means we're gonna have the sepal and sepal width, petal and petal width. Those features will be there. Iris of data will be 0, 1, 2. It will be like whether it is a set of virginica and vesicolor based on the feature values. So here you see we are having four values, right? This first value is sepal, second value is sepal width, third value petal, fourth value is petal width. That's it. Okay, like that we are having multiple records. Okay, I think it will be like nearly 100 plus records. And the target value we are having simple things. So like 0, 1, 2. 0 means I think 0 is Setosa, then it's Virginica, and then vesicolor. Okay, hope the same thing. Okay, I'm just mentioning properly. Okay, then yeah, these are the four attributes we are having: sepal and sepal width, petal and petal width. Okay, these are four attributes. And yeah, these are all about the data set. So we are having x, which is our input. Okay, that is sepal and sepal width and petal width. Then y will be our output. So we are having 0, 1, 2, like that. We have loaded our data set. What's the next thing? We need to summarize our data set. Simple thing. Okay, x dot shape, and then I'm just printing the first top 5 records. And we just see I'm just using XC inside the PD dot data frame, so that it becomes a frame kind of thing, table kind of thing. I'm giving the iris dot features as a column name. So now we will be having a top 5 records of sepal and sepal with petal and petal. How we are getting this column name? Because we have passed our input X to PD dot data frame, so it converts the data frame, and we are just giving the column names as iris dot feature names. That's it. Okay, perfect. Now I'm just printing the shape of it also. You just see 150, 4. So that is we are having 4 features: sepal and sepal with, petal and petal with, and we are having 150 records. Okay, perfect, right? This is what the summary. Let us go for pre-processing next. Okay, I hope like I'm going to apply the standard scalar to this thing, because you can see The first column we are having 5.1, whereas this column we are having only the values in a range of 1.4. When compared, you just go for the last column. See, we are having 0.2. So that is a major variation, right? Like I will say 5 is an integer value we are having in the first column, whereas 0.2 it's like negligible value when compared to 5, right? So we're gonna standardize the thing. So that is -1 to 1, like that we're gonna make it. So simple thing, I'm gonna import the standard scalar. So scalar is the value, scalar dot fit transform of my input x. That's it. If I print the first 5 values, right, I'm just passing this x scale. That is what my scaled output now. Okay, that is -1, some value, -1 to 1, like that. Okay, all the value will be in the same range. So pd dot data frame, I'm just passing this standard scalar scaled value, columns equal to iris dot feature name, and then printing the head. So you just see here, now we are having a value from I think -2 to 2, whereas here it has 5, and then there is 3, and then we are having 1 and 0 point values also. So compared to this one is more generalized. We makes our data in the same scale. Okay, hope you guys can able to understand, right? Now next thing, this is what the standard value that we are having. Next, now we're gonna segregate our data to input and output. For k-means clustering, we only need the input. The target value is not used. Why, guys? Just ping in the comment section why we doesn't need the target value. I will give a minute of time. Just look into it. Why we doesn't need the target value. Hope many of them are able to answer. Why we doesn't need the target value? Because it's a label. We are looking into k-means. It is unsupervised learning. We doesn't need a label, right? That's the reason we doesn't need y. We just need x. That is scaled x we need. After applying standard scalar, we need that x. That is x scaled. That's it. Okay, hope you guys can able to understand. Okay, yeah, this is my x, and but I doesn't need this. Okay, because like it's very rich. So this is x scale variable. Once we apply standard scalar, we get the standardized way. Now, what I'm gonna do means I'm gonna create something called as an elbow graph. Guys, this is the reason I just asked you guys to go through the previous session where we have explained what is elbow graph. Okay, please make sure that you guys watch the previous session video so that you guys can able to understand it properly. Elbow graph means simple thing. This is what the elbow graph. That's it. We have a straight line. At some point there is an elbow. We need to choose that point as our so you can see the entire thing, right? So you're gonna have a hand. So this entire thing is okay, and you will be having elbow. Some point you will be having elbow, right? This is what the elbow graph also do. Okay, you're gonna see the visualization. At that elbow, what is the value? You can take that. That is what how much clusters you need. Okay, let's hope you guys understand. Now we will go to the code part. What we're gonna do means we're gonna find within cluster sum of square, that is WCSS. I'm gonna create a for loop where I'm gonna iterate. This is a k-means model. I'm gonna iterate from 1 to 11. That means 1 to 10. Okay. First of all, number of clusters that I'm gonna choose is 1. Second time 2, 3, 4. Like that I'm gonna do, and I'm gonna fit this model onto the x scaled. That is my input. Fit means we're gonna train. First, I'm gonna train with single cluster, then 2 cluster, 3 cluster, 4 cluster. That I'm gonna cluster. Then whenever I just train it, I'm going to find the error by using k-means of inertia. I'm just passing to the list called as WCSS where I'm going to store everything. Now I'm going to visualize it. plt.plot of range of 1 to 11, that is 1 to 10 values. I'm plotting the WCSS, that is within cluster sum of square. Okay, where we have stored everything right in this list. I'm using a marker of dot, so it will be like a circle kind of thing. I'm using a title of elbow method, and then my x label is number of clusters, whereas my y label is WCSS, and then plt.show. That's it. I hope like these are the things that you need in order to make the elbow graph. Okay, perfect, right? If you guys have any doubt, just let me know. Okay, see the elbow graph. I hope you guys can able to see, right? Is it visible, guys? I hope is it visible properly. Okay, so the title is elbow graph. In x-axis we are having number of clusters, and y-axis we are having within cluster sum of squares. Okay, see here, when I have one cluster, the error is 600. Two cluster, the error is nearly 200 plus. Three cluster, it is like 100 plus. Four cluster, it is like somewhat near to 100, like that. Okay, these are the error value. It is keep on decreasing. Okay, as I mentioned, right, it is a elbow method. Okay, we are having a straight line. There is some curve. Guys, tell me, one cluster, two cluster, three cluster. After that, everything same. So we need to pick a elbow. From this we can see this is a elbow. That is a shape, right? 1, 2, 3. So third cluster, three clusters we need to take. Based on the strategy, we have fixed what is the number of clusters. So now the cluster value is 3. That's it. Now we go further. Now I'm just loading the data set, loading the model, k-means model with n clusters equal to 3, because based on the elbow method we have found 3 for our data set, iris data set. Now simple thing, once we loaded it, we're gonna fit predict. That is, it will train and it will also predict the answer. Okay, it's a new thing, right? We used fit, it is used to train. We used predict, it is used to test the data. Whereas fit predict means it will go for training as well as prediction. Okay, fit predict x scale, it is our input, scaled input. So this y k means is the value which is predicted by our model. You just see it is able to predict this or the value. So 0, 1, 2, like that. Okay, that's it. Okay, we have found the number of k values based on the elbow method. We have applied the k value to this model, and this only 2 lines case. Okay, loaded the model with the k value that we have found in the elbow method. Then we have predicted, and we have just get the answer. Now I will show something which is, I will say, very interesting. Let us visualize it. What I'm going to do means, I'm going to create a scatter plot. Plt.scatter, scaled input, that is my input. So y k means is the output which is predicted by the model. 0, 0 means that is 0th value. 0, 1 means it is prediction as 1. 1, 0. 2, 0 means it's a predicted as 2. Okay, here we are having values, right? 0, 1, 2. That is what I'm saying. Scaled input, my model's output 0, 1, 2. Since I need 2 dimension in order to print the scatter plot, I'm just using one more thing as 0. Similarly, next thing, scaled thing, and then I'm using the same thing. Okay, I hope like you guys are able to understand, right? 0, 0, then 1, 1, 2, 2. Only these things you can see 0, 0, 0, 1, 1, 1, because I need 2 dimensions. Okay, that's the reason I am just putting 0 as a first dimension, 1 as a second dimension, and within prediction first will be 0, 1, 2. This is for dimension 0, whereas for dimension 1 similarly 0, 1, 2. That's it. For a scaled input, I am passing the value which is predicted by our model. Y means yk means, and this 0 and 1 are the 2 dimensions. I am passing the value 0, 1, 2, 0, 1, 2. That's it. And I'm just printing the size of it, where S is the size 100. The circle should be 100. That scatter plot circle should be 100. I'm just defining color. It's red, blue, green, and then I'm just defining the label also. Cluster 1, cluster 2, cluster 3. Then I'm going for one more scatter plot where I'm gonna need a centroid. I hope you guys understand. Okay, because like previous session we have discussed about centroid, right? Whenever the data points near to centroid, it becomes a group. I'm just plotting that centroid also. It's simple. K means, okay, what is K means? It's a model name. Okay, dot cluster center of 0. Similar, so this means this nothing means it's gonna take all the rows. 0 means is the first dimension. Similarly, cluster center, K means of cluster center, nothing. So 1 means is a second dimension. I'm fixing the size as 300. Here yellow color is a centroid, and then labeling it as centroid. Hope you guys can able to understand, right? Now, the next thing is title. K means clustering of iris data set. Then, what is my X label? Feature 1 standardized, Y label feature 2 standardized, and then I'm just plotting the legend so that this labels will be coming out. Okay, if you doesn't plot plt.legend, label will be not there. And then show. That's it. Hope you guys can able to understand, right? What I have done here means I have just created a visualization, guys. Just 0 and 1, 2 dimension. So in the first stage, I have passed the values this is predicted by our model 0, 1, 2 to the 2 dimension of 0 and 1. Here I'm just getting the centroid 0 and 1, 2 dimension. That's it. I'm just plotting it out. Okay. If you guys have any doubt, just ping in the comments. We will take up and we will solve your doubts. Okay. I hope you guys can able to understand. Just see the visualization. It's look great, right? In x-axis we are having feature 1, in y-axis we are having feature 2, and then K means clustering of iris dataset. Red color belongs to cluster 1, blue color belongs to cluster 2, green color belongs to cluster 3, and the yellow color is centroid. This centroid, this all data points belong to this centroid. This centroid, all the green point belongs to this centroid. Blue point, this centroid, so these blue points are belong to this cluster centroid. Guys, can you able to understand? It's interesting, right? We have seen a visualization where we are just creating a cluster. Okay, hope you guys can able to enjoy. Okay, now this is how data science guys. Okay, we have created a iris data set. We have loaded it, we have applied the like k-means algorithm, we have done everything, and we have just able to visualize it. Now I hope like it's a complete understanding from a scratch of loading the data set, loading the model, training it, and then visualizing it. Everything comes under this. Okay. So yeah, hope you guys able to understand this. If you guys have any doubt, just ping in the comment. We are here. We will just take up and we will solve your doubts. Okay. So yeah, sir, over to you.
Yes, yeah, guys. So let us understand how to apply. So, guys, if you have come to this session, go and watch all the previous sessions. So, watch all the sessions properly and 5 to 10 times, absorb the information, digest, and apply. So, now here, mimic and imitate how we are doing. So, do the same kind of thing, make a project application. So mimic us, imitate us so that you will have hands-on experience. Okay, keep doing it simultaneously while you are watching these sessions. Okay, so application. Okay, so unsupervised learning k-means clustering. First, we have to import the libraries. That is a standard constant step which we have to do. We have to import NumPy, Pandas, Matplotlib, okay, sklearn dataset. We have loaded iris dataset, and then sklearn dot pre-processing. We have to standard scaler we have to import, and then sklearn dot cluster k-means, which is we are using, and sklearn matrix, okay. So Silhouette score, which we are using for the checking the score and stuff. Okay. So then step two is loading the data set. We are loading the iris uh, equal to load iris data set x and y iris dot data and iris dot target. So those are the variables we have to define for the data set. Okay, then we get the data output, iris data. Can we go little down? Yeah. So this is the output for the data. Okay, great. So then we go, yeah, then we go to the, yeah, this is the target variable. We've given this, and you have x and x array, and then we go to y array, and then we are going to summarize the data set and print shape of the data set, x dot shape, print the first 5 rows of the data set, pd dot data frame, x column, iris, feature name, and dot head. So you get the head of it. Okay. Then you get the head of it and shape. You can get tail also, same dot tail you can write, so you'll get that. Step 4, we have to do pre-processing. Okay, and it is always a good practice to do that. So x scalar equal to, like, we have to do first define the scalar standard scalar. Okay, then x scaled equal to scalar dot fit transform x, print scale dot data set first 5 rows, pd dot frame x scale column equal to iris feature name dot head. Okay, so you get the outcome according to this. So sepal width, petal width, sepal length. So you get uh, these features printed. Okay, you print the, yeah. So you get then x scaled. You get this array and output. Then we do segregating the data set into input x and output y. So for k-means clustering, we only need to, like, input feature of X and then target label Y are not used. Okay, so that you have to remember. So then you get the output of X, that is this array. Okay, then you get X scaled. This is the array for that output. And then we do step 6, which is finding the optimal number of clustering using elbow method. We've learned in the concepts what is elbow method. Okay, so WCSS equal to um, um, and we do, this is the within cluster sum of square. Okay, WCSS for, okay, for I in range 1, 11, K means clustering equal to I, K means fit, X scaled, WCSS dot append, K means dot insert. What is this? K means dot.
Yeah, it's fit, sir. Fit.
Okay, okay.
It's fit.
So once you do this, and then you have to do plotting of elbow method result. So you get this elbow method. You can see it's like elbow. Like we have elbow, same way. That's why the name is elbow. Okay, so you can see uh, from 600 WCSS at 600, and uh, can you go a little up? Yeah, number of clusters we have 10. So this is how it looks like. You can see it's an elbow shape. That's why it's called elbow method. Okay, can we go down? Yeah, can we go? Yeah. So then we have step 7, K means clustering. From the elbow method, we choose 3 clusters. As we know, Iris has 3 species, which means K means equal to K means N clustering equal to 3. Y K means equal to K means dot fit predict X scaled. Okay, then you get Y K means. This is the output array. Then we go and visualize the clusters, step 8, and we do, yeah, we do plot dot scattered X scaled Y means. Okay, so equal to 0 0 X scaled Y K means 0 1, S equal to 100, C equal to red label cluster 1. Similarly, we do it with X scaled YK means for other clusters, cluster 2, cluster 3, and then we are going to plot the centroid of the cluster. That's also we have to do, because that will show us the centroid for the cluster. And then we write plot dot scattered, K means clusters centers, 0 K means cluster centers, 1 S equal to 300, C yellow label centroid. So we are differentiating. We want to give different colors so that we can differentiate where is cluster, where is centroid, okay, where are other data points. Okay, so plot dot title, K means clustering for iris dataset, plot dot X label feature 1 stabilized, plot dot Y table feature 2 standardized, plot dot legend, plot dot show. Okay, so now because when we define each and everything, then we get the output. You can see centroid for green is here, for red it is here, cluster 1 which is red, cluster 2 which is blue, centroid is here, and then cluster 3 we have green, centroid is here, and then centroid is yellow, you know that. Okay, so it is on feature 2 stabilized, and then you have feature 1 stabilized. So these are two axes we are measuring this data. K means clustering. Okay, data set. So let's move to the 9th step, evaluating the clustering performance using a Silver score. So we have to SIL score equal to Silver score X scaled Y K means. So this is how we'll get the score. Print Silver score for 3 clusters SIL underscore score. So you get the silver score around 46%, okay, for 3 clusters, which is the average, okay. So we have learned that we'll get best performance only when we make different clusters earlier sessions in concept. So when we make different clusters, different groups, segments, we've learned, I think, in k-fold, okay, we make different k-folds and then we get best average performance, okay. So it's kind of that, because then it will, so the number of iterations you do, you will improve your score, not a problem. Let's move to the other step.
Yeah, that's it, sir.
That's
That's
it,
right.
guys. Keep learning deeply, understand all these concepts properly, absorb the information, digest the information, and apply. So, have a long term objective, have patience, consistency, persistency, and perseverance. So, you'll become world's best data scientist, AI ML engineer, or AI researcher or scientist. Keep learning deeply. And if you have any questions, write in the comment section. Also, subscribe to our channels, also press the bell icon so that you will get notification for each session, and keep learning deeply, guys. And if you're choosing us, choose us, get results. Don't keep moving here and there. Just focus on one thing, learn from it, then move to the other thing. Keep doing less is doing more, guys. Understand that, and keep learning with focus, consistency, persistency, and long term vision. And do all the assignments, this project. And if you have questions, write in the comment section. Also, do all the quizzes. We have more than 200 quizzes. So do all the quizzes so that you will deepen your knowledge and skill. Keep learning deeply. Thanks.
Yeah, guys. Actually, I have just missed this one. Okay, actually, sir has explained this. Okay, it is like a calculation of accuracy score for classification or to score for regression. Okay, just we need to just import the silver score, and we need to give this x scaled is our input. Guys, just listen. X scaled is our input. Y means is the value which is predicted by our model. When I put this to, that silver score is nearly 46%. It's less, but like okay, we are just learning, right? So this is how. Okay, in accuracy score and R2 score, the parameters is different. First parameter is the parameter what is the y value present in the data set. Next parameter is what is the y value predicted by our model. Here it's completely different. This x scaled is our input, scaled input, whereas this y means is the value which is predicted by our model. That's it. Okay, so I want to just explain this. Okay, as sir also explained this betterly. So yeah, this is everything, guys. So we have today we have looked into the k-means coding session. It's great. Okay, actually today we have just seen a visualization how the clustering works. Okay, I'm very happy to show this. Okay, so yeah, guys, that's all about today's session. Make sure you guys watch this session. If you guys have any doubts, just reach out to us through the comments, and we will take up and we will solve your doubts. Guys, till now, if you guys doesn't subscribe to our channel, just subscribe to our channel, because like every day we're gonna upload a video so that you cannot miss anything. So just press on the bell icon so that you will be getting notification whenever we just uploading the video. So yeah, guys, make sure you guys watch all the sessions, so you have learning each and every day. So it's a step by step learning. We cannot become a data scientist in one day. Okay, so the program itself, it's a year long program, and we are here to help you to become a data scientist, successful data scientist. Okay, so yeah, guys, so until next session, guys, bye. So take care, guys, bye. We will all meet in the next session. Bye, guys.
Take care, guys. Build long-term objective function, which is like a career objective vision, so that you will keep learning with consistency, persistency, and long-term objective function, patience. Okay, with these skills, you will become world's greatest learner and lifelong learner. Keep learning deeply. Thanks.